Hello, everyone, and welcome to this event on our online pollution and environmental control course. So thank you very much for taking the time to join us today. My name is Xavier, and I'm one of the course advisor team for online and blended courses at the University of Manchester. We're here to help you and answer any questions that you might have about our courses and guide you through the application process. So today, if you are considering studying pollution and environmental control with us online, this event is an excellent opportunity to meet the academics behind the course, learn more about the course, and have any questions answered. So feel free to use the Q&A function or the chat box and interact with us. Actually, I invite you to write right now a message to the chat and let us know who you are and where you are joining us from. That's always very interesting. So if you are watching the recording back, I know that some people expressed interest in joining us today, but couldn't be, were not able today at this time. So, or if you have any question after the session, please feel free to contact me at studyonline@manchester.ac.uk. You can see the email address at the bottom of the screen here. You can contact me anytime and I'll be happy to help. Today, I'll be mainly facilitating the session. We are going to start off with some introduction from the panel. I'm very pleased to be joined today by the Fab Four of Pollution and Environmental Control in Manchester. We're here with the course director, Andrew, and the units coordinators, Steve, Paul, and John. So I will invite them shortly to introduce themselves and give you more background on their career and academic interest. Then we will move on to a detailed presentation of the course, and finally we will open things up to the Q&A. So shall we start with the panel introduction, and we'll start with Andrew, our course director.
Hi everyone, so I'm Andrew Lowe. I'm a senior lecturer here at Manchester. My background is in hydrology, predicting flows from big mountain basins. That's what I'm interested in. But as Xavier said, I'm the program director for MPEC Online. And I've been at the university 4 years full-time and 12 years part-time. But before then, I spent 20 years in industry, in environmental consultancy, working mainly on water resource, hydrology, flood forecasting projects all around the world. And you can see on screen there some of the countries I've worked in. And I try and bring that real world exciting experience to the course materials and teach you some interesting projects, I hope. And most recently, I was working before joining university in southern India, in Chennai, and in small flashy catchments, looking at flood forecasting in Australia near Byron Bay. So that's a nice site visit during that project. But my research interests are in hydrology, modeling. I'm working with Steve Boult, who's on the call, looking at predicting flows from peak catchments in the Peak District, which is near Manchester, and also continuing to work in water resources in East Africa and forecasting in Pakistan. Thanks.
Thank you, Andrew. Steve, the floor is yours now. Steve, something I can hear you.
Hi, I'm Stephen Boult. I deliver 2 units on the programme, and my background really, I'm interested in the movement of pollutants. I've looked a lot at heavy metals, and now I look particularly at carbon as a priority pollutant. I look at the way that carbon interacts with metals as well. So I'm also very interested in environmental monitoring, and I have a lot of industrial links for environmental monitoring. A lot of these through the company that I run, which makes environmental monitoring equipment. So I run a business as well as being a lecturer, and we make a wide range of environmental monitoring equipment, largely for water monitoring, but also for gas monitoring. A lot of that's to do with pollution control, but a lot of it's also to do with asset management. So asset management in the water industry, and then cutting across to managing brownfield land and studying gas movement in the subsurface. So I'm working towards increasing the size of data sets for environmental systems by using this kind of new monitoring equipment, and then moving towards more data-driven modelling away from the modelling that's gone on typically in the environment. And I think that's something that my colleagues, particularly Paul, are particularly interested in as well. I think that's all that I need to say. Thank you.
Thank you, Steve. Thank you. Next one is Paul.
Hi, I'm Professor Paul Connolly. I'm Professor of Atmospheric Physics in the department, and I use atmospheric models in my research. But I also use a large cloud chamber experimental facility at the university that I'm responsible for. It's called the Manchester Ice Cloud Chamber. It spans 3 floors of the Simon Building, and we can cool it down to minus 55 degrees Celsius. So this is an important part of my research. And we can simulate a range of atmospheric processes in the cloud chamber to learn about these processes. For instance, we can look at snow formation processes, and we can look at cloud formation on pollution particles. And we can also look at secondary ice mechanisms. In fact, we recently discovered a new secondary ice mechanism that we think is really important in the atmosphere. And what do we use all of this for? Well, we use it to improve weather and climate forecasting. And I collaborate with the Met Office to do this. So on the module, I also coordinate the module on the course, sorry. I also coordinate the module Measuring and Predicting 2, which focuses on using and interpreting numerical data. And that's me. Thank you.
Thank you, Paul. And last but not least, we have John with us. John?
Hello. So my name is John Pittman, and I'm also a senior lecturer here at the university. And I teach one of the units in the course in the first semester. I've been teaching on the NPEC program for about 10 years, just over. My background is as a biologist, and I'm interested in understanding how biological organisms, so particularly plants and other microorganisms, respond to environmental challenges, particularly in response to pollution. And as part of that work, as well as understanding some of the toxicity responses, adaptation responses, my research is also interested in understanding how we can exploit natural processes to mitigate some of these challenges. So how we can potentially use biological organisms to remediate and clean up polluted land, and look at the adaptation of organisms to restore and recover polluted environments. And many of these things we also touch on in the unit I teach, but I'll talk more about in a moment.
Great, thank you very much, John. So just a quick reminder for those who have joined us a bit late, you will have the opportunity to ask your questions, and they will be answered at the end of the session. Please use the Q&A function or the chat, and you will be able to ask your question there. But I leave the floor now to Andrew for a general introduction of the course before we go more deeper into each unit. Andrew, the floor is yours.
Great. Okay, so I'll give you an overview of the course. So the online, NPEC Online is an online version of the well-established NPEC course that we run on campus, which has been running for 45 years. And we've designed it so that it's, as an online course, extremely flexible, so that you're able to balance the course if you're working or studying or have family commitments, to work at home. So there's no need to relocate to Manchester, obviously, but it's very much for people who are in work and there's no need to pause your career when you undertake this course. And the content is high quality. You're working with leading edge researchers at the university, and we try and talk about and teach and use practical data sets that the team have worked on in their research careers, and we try and give you skills to take into your workplace. Next slide, please. So it's 100% online. We have a delivery platform, a virtual delivery platform called Blackboard, which hosts all the lecture videos, the online slides, the online tests. We have transcripts. We have a rich content for you to view for each of the course units. The advantage is you can study full-time or part-time, and that part-time option is quite attractive to those in work who have got jobs, so you can better balance your career as well as studying for a master's. And the part-time option we'll come to later. You can choose from 24 months to 36 and so on, to a maximum of 60 months. So we're very flexible in how you undertake your online course. And it's, as I said, it's established in parallel with the long-established online on-campus course. And the next intake is in September this year, 2024. Okay, so let's talk kind of generally about the course. So certainly all of us try to use case studies in our course units, and these are often real life case studies using data. We try and focus on real world applications. We introduce you to virtual field trips, so you can look online and get a similar experience to those students who are on campus. And you will undertake a research project as part of the MSc, and that tries to tie together all the information that you've learnt on your course units into a research project. And often those research projects are built around real world type problems and research. As I said already, you can choose between full-time and part-time. You can set your own schedule, very flexible. All the information is accessible online 24 hours a day. Got access to the libraries, got access to software. A lot of us use different types of software or programming languages on our courses. You've got access to remote computers to undertake the coursework that involves computer modeling. So you get good hands-on experience with software, programming, and virtual fieldwork. Okay, so how will you study? Well, on screen there is an example of the calendar for a full-time student, if you want to do it remotely but full-time alongside the on-campus students, and we can see there all the course units listed. And then there's a part-time option, a calendar showing you the part-time option over 27 months or a 2-year program. And we've obviously got other options for part-time as well. That extends up to 60 months. So what will you study? Well, on screen there is a list of the talk component. So each semester you will undertake 60 credits of coursework. Each of the courses listed are 15 credits. And then in the second semester, you can see those courses listed, all 15 credits, 60 credits per semester. And then the final MSc project, the research project, is taken over the third semester if you're full-time, and that's also 60 credits. And that's why the part-time course is 27 months. So we allow enough time for the research project if you're part-time over 2 years. So we're going to now talk individually about our course units that are listed in that table.
Yes, so, and I think it's Steve starting with measuring and predicting, part 1.
Measuring and predicting part 1 is the first course that you'll do. It's in the first semester. It's actually has several objectives because it is a preparation for your research project, which you'll be doing in the third semester, or as you're doing it part-time, that may be some other time later. So it's preparation for your research project, but also it's preparation for the second semester course that I teach as well. So it does start out by talking about research in general, which is preparation for doing your research project. But then it goes particularly into ways of making measurements in the environment, particularly trying to recognize the problems in making measurement and the quality of data that you get by making measurements. So that's the measuring part of it, and also introduces you to simple modeling as a way of predicting. So a way of using measurements and extending from measurements. So in many environmental systems, we can't make all the measurements that we would like. And consequently, you have to fill the gaps in. And filling the gaps in generally involves some kind of modeling. So the simplest concepts of modeling are developed in this unit and developed a bit further in part 2, which Paul teaches, and then also developed a bit further in the second semester when I do my course on pollutant mobility. There's lectures and videos that explain concepts and then take you sort of by the hand through the exercises that you carry out. And there's also some demonstrations of equipment that are used for making measurements. Part of that is done through one of the things that we do is to carry out a small project using data that's been collected from the field. We'll go through the way the data's been collected, and then you analyze that data that's actually been collected on the real project. The pictures there show some of the things that we do, where some of the data comes from. So we've got groundwater and surface water, measurements of the movement of groundwater, and characterization of surface waters and groundwaters, chemical characterization. I think that's enough for measuring predicting part 1.
Great, thank you. There's part 2 with Paul.
Yep, so I coordinate the module Measuring and Predicting Part 2. It's also in the first semester, but it's the second part of the semester and follows on from Steve's course. This course unit focuses on using and interpreting the output from numerical models that you use in the practicals. And I really believe that using, by learning by using the models, it's really powerful. It's a powerful technique for you to learn how these processes act in say, the atmosphere or other systems. And so we cover relevant theory in lectures, but to see how the different mechanisms affect properties such as the climate, the weather, rainfall, and droughts is a really powerful learning technique. The models that are used in this module are, there's a cloud and aerosol parcel model. That's one of the models. There's also a Gaussian plume dispersion model. We're looking at how pollution is dispersed in the atmosphere. There's a single column model of the atmosphere where we can look at how pollution particles affect surface precipitation, so rainfall. And there's also a shallow water fluid dynamical model where we can look at weather forecasting and also tsunamis. And so we do some preparation to learn about techniques, the modeling techniques in general, and we learn about common pitfalls or issues with modeling. So for example, what they can be used for and what they shouldn't be used for. And here you can see the web page for the model. This is actually an older version of the web page, but the key point is that it's a simple layout with all of the available materials for each week. And there's interactive activities that check that you understand the main points. I think I have another page, if you can move on. So there are extra pages each week that cover the practicals in more detail. And this particular one is of the single column model simulation. And the top left plot here shows clouds forming as the atmosphere interacts with a hill. The hill is the red data that you can see on this plot. And the top plot shows what we call the cloud droplet number concentration. It starts off at about 100 per centimeter cube, and it drops off very quickly. Why? Well, if you move down to the bottom left, you can see why, and that's because raindrops form. So this is the raindrop concentration from the model, and we can see when the air is lifted over the hill, we start to get the rainfall, and it falls on the upward side of the hill. And downwind of the hill, we tend to see there are no clouds. So this can produce situations where you have a vastly different climate, both upwind and downwind of a hill. So top right is the total mass of the cloud, the mass of the cloud water. And as you can see, as the air is lifted over the hill, it becomes lifted over the hill, more liquid water is condensed. And that's because the air gets colder as we move higher up through the atmosphere. And more liquid water can condense onto the particles, they become larger and eventually fall as rain. So we learn about the different factors that affect things like precipitation, things like pollution aerosol particles or different types of aerosol particle in this particular practical. And we also learn about different atmospheric processes. And each week you do a similar practical to this. And the idea is that you learn about the models and you use them and you learn about how to interpret the output. And that's the end of my section. Thank you.
Great. Let's go to Unit 3, then human impacts on the biosphere with John.
Okay, yes, I'm the unit coordinator for this unit, and in this unit, you will examine how various human activities have had a consequence to our planet, and particularly to the biological component on our planet. So how various activities caused by human processes have potentially challenged and damaged our natural ecosystems. And we look at 4 main themes. We look at the consequences of intensive agriculture, the consequences of resource extraction, so particularly from mining and particularly focused on metal pollution. Also, we also touch on radionuclide pollution from radioactive waste. Then we look at some of the consequences of urbanization, particular focus on the impacts to freshwater ecosystems. And then finally, we also touch on some of the challenges of air pollutants, particularly those generated from transportation and the consequences that those air pollutants, such as nitrogen oxides and ozone, have on natural ecosystems. A lot of the content in the unit lets you understand some of the processes by which these challenges take place, particularly focused on understanding some of the reasons why these various challenges may lead to a change in ecosystem structure, a loss of biodiversity, but also the consequences that has to our own human society, such as the ability then to be able to produce food, so implications to food security and to water security. But we're also looking at solutions. So we look to understand what are some of the potential solutions that we have in place to address some of these issues in a more sustainable manner. So through the course, we make use of specific examples and case studies to illustrate some of these challenges. And you'll have opportunities to look at some data that's been generated through some specific examples, and we go through some data analysis. And there are group activities by which you will collectively perform data analysis and then present your findings to the class and your recommendations based on your analysis of that data. We also have workshops where you will understand some specific components of a course in more detail, both through the study of research papers from the journal literature, and also by looking at specific problems, which also allow you to get practice and training through being able to successfully tackle the assessments in the exam for this unit. And just some photos here to show some of these key challenges that we're going to look at. So clearly we're aware that our human activities through very large scale monoculture agriculture through to extracting resources through mine sites and industrial activity is causing substantial pollution to our planet. But one way we're going to look at this is then what are the sort of sustainable approaches that we can consider to mitigate some of these issues, as well as, of course, continuing with the economic and industrial need of the planet. So can we move towards more sustainable production and consumption processes? And then finally, all of this is considered with the backdrop of climate change, which is obviously affecting some of many consequences to our planet. And that's kind of an overarching theme that is also considered in the background. So I'll end it there and move on to the next unit.
Thank you, John. And so we are with Pollution Management in Practice Part 1 with Andrew.
Great. So I teach semester 1 course. It's a research training type of course. So it's trying to simulate a research project or consultancy style project using real world data. So it runs with a lecture introducing the theory and the content, followed by computer practicals. And so we work with real world case studies that I've worked on in my career. And we focus on 2 case studies. One is based in Ethiopia in a lake system in the Rift Valley called Lake Awassa, where we look at the impacts of pollution and water resources to the lake through climate change, urbanization, increase in agriculture for food security, erosion, these sort of issues. Then we also look at a project in the UK along the River Severn, looking at flood risk to an urban community. So we're looking at kind of urban environments here in the UK and an urban environment that's next to Lake Awassa in Ethiopia. And what we do, we go through a project cycle. So first of all, we learn about the catchment. So we use geographical information systems to understand the physical characteristics of the study basins. We do virtual field trips, looking and understanding the hydrological response of these catchments. Then we start project planning. We start looking at data. We start conceptualizing the problem. We start writing our method statements, and we plan our work. And by mid-semester, we then start using the computer models to investigate some of the problems in these 2 case studies. So then we work through those case studies using industry standard software that's used here in the UK and around the world. And we start, like other courses, start thinking about the problems and solutions and recommendations. By the end of the semester, we ask you to present as a group, in a group, your findings from your analysis, your computer work, the output from the models you present, and importantly, what are your recommendations? We talk about recommendations to improve the modeling or recommendations to help solve some of the problems that have arisen in these 2 case studies. So that's my course unit. So it's a simulation of a research or consultancy project to give you a bit of research training before you then move on in the summer to your research project.
Thank you, Andrew. we move on with Unit 5, Pollutant Mobility and Transformation with Steve.
Sorry. This is the first of the second semester units, and it does follow on partly from my first semester unit. We use examples in order to teach general concepts. So these are actual clear examples of pollution, and we're using these to teach concepts and skills around measuring and predicting the pollutant controls on mobility and transformation. We start off by, first of all, defining what pollution is, which is more philosophical than most of the things that are done on the course, but it's quite necessary in order to set all of the work in context. We need to also put it into an economic context. I think that the best thing I could do is to share my screen with you, because could you just let me share the screen? Because this will also allow you to see the learning environment that we've been talking about. So this is the learning environment that we use, which is called Blackboard. And there's a home page for the unit. There'll be an introductory video, and then the learning materials are there week by week. And in this first week, we do have this bar. A critical figure for us when we come to any kind of pollution studies, we'll be going through this, is relating it to economics. And this figure is one that's central to that, which is working out the benefits of remediation of pollution against the costs. And this really drives all of the work in pollution and environmental control, because you're trying to work out whether it's beneficial or not to do it. And all of that in the end is set against real costs. We'll have some arguments about whether you think that's an acceptable thing to do or not. But that's generally the process that goes on. And then if I go back to learning materials, the other things that we cover are, we deal with natural processes and how they're changed by the impact of pollution. We study particularly water. Paul's covered some air pollution in the first semester, but we're covering mostly water and the transformation and mobility of pollutants in water. So we look at water chemistry particularly, and we define the controlling gradients that control the behavior and speciation of pollutants on this planet, and largely their oxidation, reduction, and pH gradients. And we'll look at carbonates, which are particularly important as the main control on water quality, and more important now because of carbon cycling as well. So the standard section on carbonates has become more and more important over the years. And then we'll look at the interaction of water with earth materials, which is responsible for mobilizing many of the pollutants that you'll be aware of, nitrates and phosphates and metals. And if I could, okay, we'll work through. So we have the interaction with earth materials. We look at how pollutant mobility is controlled by sorption onto earth materials, which is probably the most important control for many pollutants. Rather than being controlled by solubility, they're actually controlled by sorption. So we look at sorption, and then we move on to looking at the way that the fluids actually move. So we look at diffusion and dispersion, which Paul's covered in the atmosphere, but we'll look at that in the ground particularly, and in surface waters. And then we'll look at groundwater as well. And we do some very simple modeling of groundwater. And if I come into, this is, show you the way that we actually teach. So a good example, if we look at week 4. So there's learning content with videos and then exercises. And as an example, here's an exercise that you'll do, and you can see that you're taken through the exercise with videos, and there's an image. In this case, there's calculation to be done, and there's an image of that. It's an image of that here. So we go through on a whiteboard, and the image is saved, and you can look at the image. And then there's a video that takes you through the calculation. And then there's a subsequent video that takes you through how to implement effectively a small model in Excel. So those videos take you through all of that. Okay. So that's the content of the course, and hopefully give you some idea of the way that it's taught. So you can see the learning environment we use and the way that we take you through learning and through exercises as well. The final slide there is the sort of model system that we're making very simple models of, and that's looking at pollutant movement from a landfill. In fact, methane gas moving from a landfill, and whether or not it's going to cause a risk. So that's whether it's going to actually interact with any people or not. It may end up moving under the impermeable layer and seeping into the house on the right-hand side and exploding when the man in the toilet downstairs lights his cigarette. But that's the sort of thing you should be able to predict. Okay, that's enough. Thank you.
Thank you, Steve. So we go to the next unit, which is Pollution Management in Practice Part 2.
Great. This is a follow-on course unit for my first semester. So it's Pollution Management in Practice Part 2. And here again, we're getting hands-on experience with real-world data sets using real-world models. So there's a lot of software that you'll be using to try and solve some problems. And the modeling approaches that I teach start with looking at natural flows, looking at data sets in natural environments, natural rivers, in groundwater systems. We're also looking at environmental flows that are important for aquatic environments. And then you'll start this week with my students are working with water quality models. So we start looking at natural systems, how we can model baseline water quality, and then we can introduce pollutants and see how that affects the rivers and the lake systems in Africa. We also do groundwater modeling, again, to see how extraction of water from groundwaters affects the surface water conditions and so forth. Then we start looking at urban environments, urban modeling through drainage networks. First of all, looking at the quantity, looking at surface water problems, and then we look at the drainage network in terms of water quality. So we do some pollution modeling through urban systems, urban environments, and use standard industry type software to try and track these pollutants through an urban environment. And then again, look at providing solutions and modeling those solutions within these computer models. So that's what I teach in semester 2.
Thank you. The next unit is Environmental Monitoring and Modeling with Andrew again.
Yeah, so this is another course I teach in semester 2. And this is more focused on looking at monitoring, so how we measure environmental parameters, but also, again, modeling. I'm a bit of a modeler, so we focus here on giving you skills in GIS and further skills in modeling. But this is more focused, less on pollution, but more on looking at hydrology in high flow conditions and low flow conditions. So first we start off learning about floods, flood modeling, providing solutions to those flooding issues, looking at 1-dimensional, 2-dimensional, 3-dimensional models, again, developing your GIS skills, developing your data analysis skills, analyzing model output. Then we switch into my work in East Africa, where we've been looking at water resources, water stress, and how computer modeling can help provide information to decision makers. So we can look at master planning, future growth plans for urban environments, looking at the impact of climate change or development policies. We can then provide what the impact of those policies would be on the hydrological environment, on the rivers and lakes, in this case, the Rift Lakes Basin. Then I'm actually a glaciologist as a PhD student and postdoc. I worked in mountain basins in Pakistan, all around the world really, and also in the Rocky Mountains in Canada. So then I do a bit of work on glaciers, glacier modeling, glacier hydrology, and a really simple glacier model we use to talk about model parameters, sensitivity testing, and the influence of melt seasons on glaciers rather than rainfall. So that's my other course.
And so can you speak, yes, Andrew, as well about Unit 8 and the environmental tutorials?
Yeah, so this is an important course unit for us. So this is in our second semester. And this is when you work with us, with an academic in a small group environment, in a tutorial. And during this semester, you'll be learning about your research project. So you'll be starting to read about your research project, starting to write your research proposal. So through this semester, you're working with that academic to build up your introduction, your aims, your objectives, your specific introduction, and really start planning your method statements. Try and thinking about the feasibility of your research project. So we very much spend semester 2 thinking about the project, learning about it, doing our reading, writing our introduction, and producing a research proposal. And from that research proposal, we can then leap into semester 3 not semester 3, leap into our research projects and hit the ground running to start our research.
And the last unit is the research project. So if you can give...
Yeah, so that follows on nicely from our tutorial series. So this is a 60 credit unit, and this is undertaken at the end of all your taught component. And it's an important part of your degree. And the projects focus around 2 themes: water pollution or air pollution. We're also adding other themes this year, mining pollution. And you'll undertake an intensive period of study. So online, you'll have all the videos and content. In the first, after your tutorials, in the first part of your research period, you'll have a lot of information in the first 2 weeks to work through. That's videos, lecture slides, worked examples, data sets, and we'll provide you with all the data required for these projects. And then once you have all the data, all the models, you'll then progress on your own independently to produce your projects, with some drop-in technical sessions where you can either send your messages on a discussion board, contact us directly, or have drop-in surgeries where you can come and talk to us about any technical issues you're having. But they're quite good. They're brand new, these research projects, quite exciting, using data from in and around Manchester or the northwest of England. So really, really good.
Great, thank you. I think you wanted to mention the support and service that students can get.
Yeah, so Steve showed us the kind of virtual learning environment, we call it Blackboard. And so you've got a lot of information on there, videos, exercises, models, etc. But there's also personal support. So the university is quite strong. You'll each be assigned an academic advisor who can meet with twice a semester if you're full-time. And those are people in the department who you can contact anytime if you're having issues with personal issues or welfare issues, or just generally struggling with the course. Also, the course unit coordinators are available to help during online office hours as well, if you have specific questions about the course units. And there's many services online at the university. There is a student hub that is on campus. So you can, if you're an online student, you'd walk into these centres and talk about any issues from finances through to stress and well-being. But these are also available for you online as well as an online student. You've got 24 access to the library services and all the services we offer at the university. And we've got a very good careers service. And all these are online, so you can arrange Zoom calls to these services. If you suffer from a disability, again, you can talk to one of our DAS advisors, disability support advisors, and get a support plan in place. And again, those meetings can be held online, so you can talk to our advisors through there. So you've got access to all the services that our on-campus students have as well.
Thank you, Andrew. Yes, I think it's good to highlight here that as a student of the University of Manchester, online or on campus, you have exactly access to the same services. So that's good to know. So thank you very much for all these detailed informations. It's now time for the Q&A session. Please use the Q&A function or the chat box if you have to ask any question you might have to our academics. Don't be shy, there are no uninteresting questions. We have received a couple of questions during the presentation. One from Natalie, who's asking if there is the option to go on the field trips in person rather than online, if they're registered for the online pollution and environmental control course.
If you're based in the UK, I assume that's. I'd have to think. We'd have to think about that one. I'm not 100% sure I can answer that straight off. Steve, have you got any thoughts on that?
I think I have to ask the distance learning people. I mean, I don't know, Xavier, do you know? That's not something that's really in our remit. We don't know that.
Yeah, I mean, what we'll have is an equivalent virtual field trip, which will provide all the information and the data from that field day, including photos. And Steve's got this very good app that students can use to walk around the sites. We'd have to get back to you on that. We're not certain what the procedure is for distance learning students joining a live site visit, or
the students that are on campus use an app to take them around the field trip, and that would certainly be available to you. So if you're able to visit the site, then the app's available to you to take you around the field trip. So that would definitely be possible.
Yes.
You know, if you turned up on the same day at the same time that the students were doing it, I'm not sure that we can stop you. What the university's policy is. That's really something that the distance learning people would have to advise on, I guess, because there's a difference in fee. So I don't know, Xavier, is that something that you know about?
No, I don't have that information, but I'll keep the contact from Natalie, and
yeah, maybe you could get back to her on that.
Come back to you, Natalie, about that.
Yes, it's slightly out of our remit, really. We provide the content. People's access to it, according to how much they've paid, is determined by the university.
Thank you. We have another question from Takunda this time, who asks if does the course require a strong background in physics and chemistry?
I'd say no. I mean, Paul can comment on this as well, but for mine, it doesn't. We teach water chemistry, similarly like John teaches biology, but it doesn't mean you need to have done a degree in these things. If you have done a degree in them, we hope that it's not completely repeating it. We're doing it with particular applications in mind. So we do take people through these, you know, the small bits of modelling that I do, you're taken through really regardless of your background. And Paul can comment on his.
Really just echo what Steve says. We will teach you the relevant physics or chemistry that you need to know for the course, and we teach it in context. So not just physics or chemistry for the sake of it, but we teach it, this bit of science or physics or chemistry is relevant to solve this problem. So it's all taught in context, is what I would say.
Thank you. Thank you. Another question for Takunda, is for more specifically for pollution management in practice, part 2, and environmental monitoring and modeling. So do we have air pollution modeling in those units?
Not in, I'm very much a hydrologist, so I deal with water environments. However, I mean, Paul, you teach not air pollution, but certainly the atmosphere. And one of the research projects is on air pollution. So during the 2-week summer teaching, although I know this is an online course, but for the teaching that's related to the research project, there is online material that teaches about air pollution. So it gives you the background in order to undertake that research project. So you could choose to do that air pollution research project.
Yeah, not strictly air pollution, but in my course, Measuring and Predicting 2, it's focused on using models to make predictions and explain the impacts of pollution on the environment. So one thing we do is to look at movement of pollution in the atmosphere using a Gaussian dispersion model. So these are often used in air quality assessments. So if that kind of interests you, that's the kind of thing we do there. But also, to some extent, in the single column model practical, where we're looking at clouds and precipitation, we're looking at the transport of pollutants in cloud water. So pollution aerosol particles and how that affects the clouds and the precipitation. Other course units may focus more on that. Andy, I think you've mentioned 1 or 2. But yeah, that's my course. So air quality, Gaussian plume modeling is used in air quality modeling and assessment, and also looking at the impacts of pollution on clouds and cloud water.
Thank you. Another question that came up is about assessments, and it's something that comes back quite often. Are there any exams for the courses, or are the assessment organized? Will there be all project-based or fixed deadline to complete? How does it work for the assessment?
So I can talk about my course units. So my semester 1 course unit is all coursework. So it's a submission of a technical report after you complete your case study and a group presentation. My semester 2 courses are a combination of what the environmental monitoring and modeling is a production of a coursework. So it's practical book and bi-weekly online tests related to the computer practicals that you undertake. So it's a combination of online tests and a practical book. And Pollution Management in Practice 2 is an exam with some online tests during the practical sessions. So a combination of coursework and exams.
Thank you. Maybe John, do you want, well, if all academics could talk about their assessment?
Yes, so in my unit, the assessment is in part a coursework component that's worth 20% of a unit marks. That's essentially a group presentation. So as a group, the group analyzes some data, makes interpretations and conclusions, and presents that to the class, and each group is assessed. And then at the end of the unit, there is an examination that is largely based on multiple choice question and some short answer question to assess the understanding of the core content of the unit.
Thank you, John. Steve, you want to?
The 2 units that I teach, they're assessed wholly on an exam. The exam's an open book exam, so you can bring all the materials from the course into the exam. It's done on a computer, and largely what you're being tested on is that you've done the exercises. The exercises are things that you write up in Word and spreadsheets that you make in Excel, and then you're asked questions about them. So again, I can, if I share the screen,
You want to share the screen? Yeah.
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 I can show you, these are the typical sorts of questions that you get in the exam. So there'd be effectively multiple choice questions. There'd be a question like this where there's a sentence that's got words missing in it, and then you need to select the correct words for it to make the sentence make sense. And then there are other ones where you're asked to, very rarely to do a calculation. Mostly it's to retrieve a calculation from a practical exercise that you've done. So you'd fill in the answer to that. And then there's another one where there's a sentence with missing words that you need to understand the concepts in order to be able to fill in the missing words. And then more where there's calculations. If you completed the spreadsheets, then you can refer to your spreadsheets that you've completed already in the exam and put the answers in. So that's for both of my units, and they're 100% based on those exams. The questions you saw are practice questions. So you get sets of those practice questions every week, so you know exactly the sorts of things that are going to be asked. And the practice questions are very similar to the exam questions. So really, if you've completed the practical work and completed the exercises, you bring those into the exam, and you can use those with your answers.
Thank you, Stephen. Paul, I think.
Yeah. Similar to Steve, my course, the course that I teach, it's assessed by online exam. It's open book. There's plenty of time to complete the exam. There are 10 questions, and the questions are a combination of questions that assess the ability to interpret model output. So you'll be given some model output and asked questions about what the model shows and what kind of things it can be used for. And also questions on knowing model strengths and weaknesses. So kind of essay-based questions, and also 1 or 2 numerical questions, which test the kind of quantitative understanding of the material. So that's mine.
Thank you, Paul. Thank you. A very specific question from Siahira. Do we study about microplastic, or, for example, degradation plastic with bacteria in the course? Is it something that is covered?
Not specifically. I mean, I do research on microplastics, so it's likely that it'll appear in the course at some time, but currently it doesn't. And there aren't any projects on that at the moment.
Great. Thank you, Steve. I think we are arriving at the end of the session now. I don't see any more questions. Just a question from Muhammad to say, are we going to get a certificate for attending this session? No, this was general information about the course, so we don't deliver certificate. I'm sorry. So I just want to thank you all. Thank you very much, Andrew, Steve, Paul, and John for the time and for providing such valuable information. I think that's been very useful. I'm just going to launch a quick poll for our audience. Please answer it if you want us to contact you again. And just as a reminder, the applications for the course are now open for the next intake. Next intake is September 24. So to secure your place, I would strongly recommend to apply sooner than later, so our colleagues from the admissions team can review your application. In the meantime, feel free to get in touch about how to apply, or if you have any further question on the course. So you can email me at studyonline@manchester.ac.uk. So we will finish here for today. So thank you very much again, and we hope to see you starting the course soon. Thank you. Bye.